First is right angle triangle. A right angled triangle. As I told you that if there is one angle right angle 90 degree, then the triangle is known as right angle triangle. So if one angle of a triangle is 90 degrees, then the triangle is known as right angle triangle. Then the triangle is known as the right angled triangle. Right angled triangle. Now we know that what is the, let's suppose this is length B here, or let me write the by Pythagoras theorem we know about that AC square in right angle triangle equal to AB square plus BC square. So this is Pythagoras theorem only in right angle triangle. Pythagoras theorem. Only Pythagoras theorem. Okay, so this must be known to us. AC square is equal in right angle triangle. Okay, for the square of one side, the right angle side opposite to right angle is always square is equal to sum of the two opposite sides for the two other sum of the squares of the other two sides. This is known Pythagoras theorem. Second, let me talk about the B point. B point is here. What is acute angle triangle? B is acute angle triangle. Acute angled triangle. Let me tell you. If all the three angles of a triangle are less than 90 degrees, or each angle of a triangle if it is less than 90 degrees, all the three angles of a triangle are less than 90 degrees, every angle is less than 90 degrees, acute angle. Okay? Each measurement of each angle of a triangle, if if all the three angles of a triangle, or not all the three, if each angle of a triangle is less than, because all the three angles cannot be less than 90 degrees, that is less than one, always equal to 180 degrees, sum of all the three angles, but each angle is less than 90 degrees, means not more than 90 degrees. Every angle is less than 90 degrees, then that triangle is known as acute angle triangle. So acute angle triangle is like this, like this is there, acute angle triangle. This is less than 90 degrees, less than 90 degrees, less than 90 degrees. Now this is here less than 90 degrees. We can take like this. Okay, less than 90, less than 90 degrees. Acute angle triangle, ABC. This PQR. These two are acute angle triangle, because each angle is less than 90 degrees. That is acute angle triangle. Okay, this is what we call acute angle triangle. Every angle or each angle of a triangle, every angle of a triangle is less than 90 degrees. That triangle is in this. In this case, no square of, or sum of the squares of the two sides is always greater than. Because in case of acute angle triangle, just like this, AB square, so this is AB square plus BC square is always greater than, AB square BC is always equal to, is greater than AC square, means square sum of the squares of the two sides is always greater than the square of the third side. Any third side we can take. This is about acute angle triangle. What about obtuse angle triangle? This is now C. A and B we have talked about, acute angle triangle, then obtuse angle triangle. What is obtuse angled triangle? A triangle in which one angle is more than 90 degrees. Because the other two angles will be less than 90 degrees. That cannot be. Otherwise, triangle will not be formed. If one angle of a triangle is more than the measurement of one angle of a triangle, you can say if one angle of the triangle is more than 90 degrees or it greater than 90 degrees. If measurement of one angle, we will take here measurement of one angle of a triangle is greater than 90 degrees. That triangle is known as obtuse angle. So obtuse angle triangle is of this kind. Obtuse angle triangle we have talked about. This obtuse angle triangle is having more than, if we write here obtuse angle triangle, obtuse angle triangle. So let me take here. Now this is obtuse angle triangle. Now this angle, the side opposite to this angle, which is obtuse angle, we write here ABC. AC square here is greater than AB square plus BC square. In this case, this side length square of the side will always be greater than sum of the squares of the other two sides. Because in case of right angle triangle, this is equal to this. The side opposite to right angle is always equal to Pythagoras theorem. But in case of obtuse angle triangle, the side opposite to this obtuse angle is the largest side of this triangle. The square of that will be greater than the sum of the squares of the other two sides. That is the fact. Okay, so this is about obtuse angle triangle. Alright, obtuse angle triangle is this. Alright, now obtuse angle triangle. Now let us talk about the fourth point, the D point. The D point say what is the equilateral triangles. Now come the equilateral triangle. What is an equilateral triangle? Obtuse angle triangle we have talked about. In this case, sides are not equal. So then is a D point. Now D point says what is the equilateral triangle? D point is equilateral triangle. Okay, a triangle in which all sides have equal length. All sides are equal in length. All sides are equal in length. Okay, in that situation, so this is length A, length A, length A. And take this ABC triangle. Now in this case, because all sides are equal, the angles opposite to these equal sides will be equal. This angle equal to this angle equal to this, because sum of the three angles is 180 degree, and every angle will be 60 degree. Then this angle is 60 degree. So sum of all the three must be equal to 180 degree. 60 plus 60 plus 60, 180 degree. So each angle is equal. So in a triangle in which all the three sides are equal, it's not an equilateral triangle. Okay, so first point is some facts about equilateral triangle. So in this case, each side is equal, or every side of a triangle, every side is equal in length. This is the first thing. Second point, every angle, or as angles opposite to equal sides are equal. Okay, but sum of all the three angles of a triangle is 180 degrees. If I take this plus this plus this, take this is angle 1 plus angle 2 plus 3, whatever. So therefore each angle, if I divide it by 3, well, every angle is equal. So 1/3 of one angle is equal to 180 degree, less than, I mean 1/3 of this 180 degree. Therefore angle A is equal to 180 degree upon 3, that means 60 degrees. Angle B is also equal to, well, if I take this angle A, angle A, angle A, 3 times angle A is equal to 180 degree, angle A is equal to 180 upon 3, this 60 degree. Angle B is also 180 degree upon 3, 60 degree. Each angle is equal. Angle C is also 60 degree. Simple. So every angle of an equilateral triangle is having equal angles, 60 degree angle. So that is two facts regarding equilateral triangle. Equilateral between side, every side is equal. That means equilateral triangle. Regarding its area and other things we will talk about when we talk about next lecture series, area, perimeters, etc. of equilateral triangle, isosceles triangle, etc. And now let me get next point. Now it says in the fourth one. Okay, sorry, isosceles triangle. E part is what is isosceles triangle. Isosceles triangle, a triangle in which two sides are equal in length. That means, suppose this is the triangle here, with this side equal to this side. ABC we have talked about, and this angle, because these sides are equal, this side equal to this side, AB equal to AC, the angles opposite to these equal sides are also equal. This angle equal to this angle. So in triangle ABC, AB is equal to AC, equal in length. Equal in length or lengths. Equal in length. Alright, AB equal to AC. But angles opposite to equal sides are also equal. Therefore, angle ABC is equal to angle ACB. So, two angles are equal. Okay. These two angles are equal. Now, this is known as isosceles triangle. So, two equal-sided figure or triangle is known as isosceles triangle. Isosceles triangle is of this kind. Okay, so what is the vertical angle? Now this angle is known as the vertical angle in isosceles triangle. The angle opposite to the unequal side is known as vertical angle. In this case, this is vertical angle here. This is the vertical angle. Next point is okay in the vertical angle. Where is this? Okay, next is vertical angle. Okay, so this is non-vertical F point. Now this is F point here. Vertical angle. Okay, now if I draw, if there is a triangle, let me take this triangle here. If I draw angle bisector, this is A, B and C. This is angle bisector. Let me take this is D. So AD is the angle bisector of angle A, which intersect the opposite side BC at a D point. Okay, this is known as angle bisector. Okay. Then also this is known as vertical angle. But in case of isosceles triangle, the angle opposite to the non-equal side is known as the vertical angle. So that is there. But I'm talking about now isosceles. Okay, vertical angle. This is vertical angle. What is Apollonius theorem? That is Apollonius theorem I have to talk about. What is the Apollonius theorem? Okay, so that point let me talk about. Now Apollonius theorem says that in isosceles triangle, or sorry, in a triangle in which angle bisector is drawn, AD is the angle bisector of angle A. In that situation, okay, angle bisector divide the opposite side in the ratio of the sides containing the angle. Okay, let me first talk about. Let me change the marker. Here I'm changing the marker. I will see talk about. Okay, so talking about this vertical angle. Okay, I'm just talking about one point here. What is Apollonius theorem? Let me just think about that. Okay, this is what is Apollonius theorem? The theorem is that AB square if guys, I'm just talking about the marker is not good. I'm just selecting one marker. Okay, so I've selected this marker here. Okay, this is not filled up with ink here. Let me take this. Okay, now come to the point. So vertical angle is this. Angle bisector is B12. Okay, this is angle bisector here, or in a isosceles triangle. What is vertical angle? These two sides are equal, and this angle is known as vertical angle. ABC. This angle A is known as vertical angle. These two angles are equal. This angle is known as vertical angle. So, in an isosceles triangle, this thing was left here. An isosceles triangle, the angle opposite to the vertical, sorry, non-equal side, opposite to the non-equal side is known as vertical angle. Known as vertical angle. Okay, is known as vertical angle. vertical angle, right? Here angle A is the vertical angle. This is known as vertical angle. Vertical angle. Finished. So vertical angle is there. Now let us talk about next point. Next point is Apollonius theorem. Yeah, Apollonius theorem. Now I have to talk about the Apollonius theorem. F and this is G here. Now G option is what is Apollonius 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 theorem. What is this? Now, Apollonius theorem says that if AD is the median, if AD is the median of the side BC, median which is the median of the triangle or median of the triangle ABC, which meets the opposite side at midpoint. It meets the opposite side at midpoint. Means D is the midpoint of BC. We have taken here. D is the midpoint of BC. This is known as median, not the angle, but median is drawn from opposite vertex, or this is vertex A. From A we have drawn median which meets the opposite side in the middle point. So D is the middle point of BC. So BD is equal to DC we have taken here. So that is the point. Here D is the midpoint. Now let us talk about what is the Apollonius theorem. Apollonius theorem says that AB square plus AC square is equal to twice AD square, this AD square plus BD square. This is the point here. Angle bisectors divide the opposite side in the ratio of the side containing the angle. This was about angle bisector. And I talked about angle bisector. Not yet. Okay. Oh, but this is the median here. About median between the middle point. Then it says that AB square plus AC square is equal to twice of BD square plus AD square. This is AD square here. How to prove this? It's known as Apollonius theorem. This is known as, I'll prove that this is known as Apollonius theorem. Apollonius theorem. This theorem is fact that AD square plus BD square twice of this is equal to AB square plus AC square. We know that angle bisector divides the opposite side in the ratio of the side containing the angle. Means angle bisector. Let me write here. What is angle bisector? Angle bisector of a triangle divides. This is one of the facts here which I have not talked about yet. Okay, the angle bisector of a triangle divides the opposite side. Divides the opposite side in the ratio of these sides. The ratio of these sides containing the angle. Containing the angle here. Okay, this is about if AD is the angle bisector. If AD, suppose AD is the angle bisector, then AB upon AC equal to BD upon DC, or divides the opposite side BD upon DC into AB upon AC. This is known as angle bisector facts. angle bisectors of a triangle divides the opposite side. Suppose AD is the angle bisector of angle A, but in case of Apollonius theorem, AD is the median which meets BC at D. I'll talk about that. But in case of angle bisector, this shall be. First, let me talk about this Apollonius theorem, then I'll talk about this angle bisector theorem. Okay, so first, let me talk about this. What is Apollonius theorem? Let me write here. We have to prove Apollonius theorem, which is Apollonius theorem here. Here, AB square plus AC square equal to twice of BD square plus AD square. This we have to prove. Known as Apollonius theorem. Okay, so Apollonius theorem. Let me prove this. This is the proof or solution of this. If AD is the median of the triangle ABC, which meets the opposite side, BC at midpoint. That means BD equal to DC. This is the first fact. AD is here, the median. Median means the opposite side in the middle point. BD equal to DC. D is the midpoint of BC. BD equal to DC. This we have to use. Now, if I drop a perpendicular from A, let me take a perpendicular here. If I drop a perpendicular from A to this, let me take this E point here. This is right angle. This is right angle here. So A is perpendicular to roof. Now draw AE perpendicular to BC. Now in these two right triangles, then right angled triangle ABE, let me take first. ABE, we have what we have. AB square is equal to AB square is equal to BE square plus A square equal to B square plus AE square here. Take this is second equation. In right angled triangle AEC, this is by Pythagoras theorem. AC square is equal to AE square plus CE square. This is third equation. Okay, and only in this simple one, ADE, in right angled triangle ADE, we have AD square, because AD is the hypotenuse here, side opposite to right angle. Okay, AD square is equal to AE square is equal to AE square plus DE square plus DE square. A square to D. This is, let me take fourth equation. This is the fourth equation. Let me take this fourth equation. Markers are not properly working. Okay, so now let me take it here. Then I'll do this job. So now adding second and third. So adding second equation and the third equation. We have AB square, this AB square. The left hand side we have added AB square plus AC square is equal to right hand side is B square, we put it here, B square plus CE square or B square plus A square, BE square plus A square plus AC square value. AC square value is A square. This is A square plus CE square. A square plus CE square. Okay, now let us take this further. Right hand side. So this is equal to, we have taken BE square. And if I write B, okay, first let me write B square plus AE square is okay. A square, twice AE square is there. Twice AE square we have taken plus CE square. What about BE? If I write in place of BE, this is what? BE means BD plus DE. BD plus DE whole square. BE means, since BE is equal to BD plus DE. So in place of BE, we have put here BD plus DE whole square plus twice AE square plus this is CE square, no problem. This is here CE square. Okay, so let us take now this value further. If I open this BD square D square, okay, let us take BD square, this is BD square here plus DE square plus twice BD into DE. This is A plus B whole square. A square plus B square plus twice AB. Okay. Plus AE square is there. Okay, this is twice AE, so let me circle that. This is AE square plus CE square. Okay, now let us take BD square is BD square